All right, welcome. I'm going to do a little bit of right triangle work. So, in school, you learn the Pythagorean theorem. It's really interesting, and but until you build with it, you don't really understand the value of it. It's u- uh, very useful, almost indispensable. Without instruments, the best way to get right triangles. And why would you want right triangles? Because everything you build basically is going to be right angles, right? Not going to help you much if you have a building that's at a square. So this ensures that you know how to get something square. And it's three, four, five. That's the right. That's the Pythagorean triple. But there's also 6, 8, 10, and then there's other ones that are. I think there's 5, 12, and 13. There's just a bunch of them. But the one that's nice about this is that it's pretty balanced. So if you get one that's, I think it is let's go 12, enter, tab 5, enter, and I think that's I'm going to go back here. 12, enter, tab 5, enter. I think that's 13. Yeah. And then, so it's a 12. So there's different ones. But the one thing that happens here is as you swing this arc and you swing this arc, the closer it gets together, the less accurate it is. But it's also very useful. I mean, just depending on what you got, because it doesn't require any calculator. So you could go. Let's typically you're gonna do 3, 4, 5 if you're laying out something in a hallway or a bathroom. 6, 8, 10 if you're laying out a corner of a wall. Maybe 9, 12, and 15. It can be any one of those triples. But there's other triples. You look them up, Pythagorean triples. This is the most common. Another. So I'm gonna explain why this is useful. So let's call this the baseline, right? And let's say that's a return on a wall, and you got to come over from here, point relative. Let's say 5 feet, -5, right? Put a point mark there. It's a big point. F3. All right. So you know this is 5 feet away, and you're tasked with creating a right angle there. So how do you do that? There's a couple ways. The 3, 4, 5. So what you do is you from this mark you swing an arc. The radius of 3. Basically, all you're doing is measuring down this right here, 3 feet. Really, swinging an arc. If you have the line there, it's not really swinging an arc. It's just creating a point there. That's the intersection there. So you have 3. Get rid of that 5. It was just a reference for that point. So you're going to go either direction, 3, and then out here you're going to swing an arc 4. You don't know this line yet, so what we're trying to do is establish that square line. That's why this is useful. So let's go to the arc at 4 feet or 4 units, right? And then you're going to go swing an arc from here. That's the 5. And then when you snap this line from here to here, that's how you get your right angle. All right, that's why that's useful and the more accurate. Like I said, this is good because it's pretty square. So that's one way to do a Pythagorean triple. There's another way to get it with a diagonal. Let's just do a. I'm going to use 5. So point relative 5, tab, and 5. That's something that surveyors are very happy to let you know that they know is 55707. So this is 5, this is 5, and this is going to be 7.0711, right? 707, and that rounds up to 701. And that's something that they'll use on a corner of a building, typically. So it was very common to get a 5-foot offset for small footings. And I think I did start something over here, something like this. So on that pin and right there, maybe say they'll leave you a stake that says 5-foot offset corner. It means the stake is facing this corner. If you're standing on this corner and you're reading that stake, it'd say 5-foot off center off the corner. Then if you're standing this way, the stake would be facing you that way. And the way to check those after you put those 5-foot offsets is to check it like that. I don't know, it'd be particularly useful laying it out unless you were laying it out on the ground somewhere, maybe on a plywood floor, a controlled environment or something. So there's this kind of skipped a little bit. So if you go, so it's called the square root of 2. So this number is the square root of 2. So I do another one, point relative 1, tab 1, enter. And the diagonal on that is going to be 1.4142. That's enough for this precision. Let me change that. Be like that. So, and then this side is this. And the reason why it's called the square root of 2 is the Pythagorean theorem, which is a squared plus b squared, which in the two legs here is 1 squared is just 1, so it's 1 plus 1. 1 squared plus 1 squared is basically just 2, and then the square root of that will give you the diagonal. So if you go tools, calculator, square root, and I'll just type it all out, 1 squared, so you see it, plus 1 squared, close parenthesis, and then you'll just end up with the square root of 2, that 1.4142 number. So that's very useful because then you can have any, so I don't know so much what survey would do with it, but I can tell you we used it a lot when we were laying out footing. So I'm going to show you an example of what that looks like. So here, let's say you're setting up here with your instrument. You're back sighting this way or turning 90, whatever you got to do to establish this line. And then you're going to chain out or use your tape maybe or total station to get your distances. And you're going to shoot, let's say this one was 20 feet away, 25 feet. Yeah. $25 feet. I think I made them all 20 feet. So you're just basically going out there. Lost the arrows. But now you've got a point and a line. So right from here to here, you basically start a little shy. You get a couple of line markers, and then you get these pins in the center of the footing. Or you could do you could do the deduction. Let's say we just did the centers because it was easier to close out on control and make sure things were lined up. And then you measure back. Let's say it's an 8-foot footing here. Point relative. Enter. It's the same thing. You're just getting, actually this one, yeah, control Y. You're just getting an intersection. Right? So you end up with a smaller point. Let's do this. That's about right. I think I messed up. All right, so that's another mark, and then you maybe do another mark up here, but right now what we need is this. And you would use that 1.4142 because this is 4 feet from here to here, and this is an 8-foot footing, so it's 4 feet from here to here. And then you swing that arc. So let's do that. So you're basically getting this one here. This is 4. Right, crossing that line. And then doing the same thing here. Swinging a 4-foot arc over here. And then you're going to go 4 times that number times 4. Enter. That's the number you're going to use. Control C. And you can swing that arc that way. Control V. And you'll be doing the same thing over here. All right, and then you do the 8-foot. You could get this one, and this one. Put your nails, so you know you're putting nails in there, and then you go from here. It's going to go 8. You could do the same thing. Put another nail there and do the same thing reflected, or you could go up and just do an 8-footer. And then do the diagonal there. Tools calculator. It was a 9. For 1.4142 times 8. Control C. And then you can swing that arc from here. And right there, 4. You've got a line here now, line there, line there. That's your right angle. And then from here, you could just swing 8 and 8. And just snap those together like that. And those angles will be Alt M A. Really going to be really close for your 90 degrees. Here it's probably going to be really close because I used the digital angle, up to 4 decimal places from the copy and paste. And then that's an example. And then over here, it would be something similar. So you're going to do an arc. 2.5. F3, F4. Oh, no, that's not working. And then 1.4142 times 2.5. Did I actually put it in there? Yes, I did, I think. F3. Yeah. That was just a placeholder, right? So then you end up with the 5-foot line right here, F4, F4. And then you could do the swing arc at 5. And then 7.07. And do the same thing that way. think that's not F3. Yeah, mistake. 7.07. And then there's your right triangle there. You can do the same thing. Swing the 5. Right, that's how you'd snap those out. And then you just did another, whatever that was. If it was a 10, it'd be 14, 14. Just do one more so you can see the numbers too. 5 actually is the same. F3. Now it's going to bring up trim. So then 5 this way. Same thing this way. Then we're going to go 5 times 1.142 to 707 again, 3. And you got those, and then do the same thing with the 10. And then you would do 10 times, it'd be 14.14. 42. Here I'm going to do it because it shows up any error will show up like it was but anyways, in the dirt you have a certain amount of error, right? So 1/8 of an inch is about as close as you're going to want to. And then the same thing out here. And you'll see these are 90 degrees. And that's the important thing is because everything built 90 degrees. You know, you're going to want to build a footing that's at a square. Anyways, that's it. So that's useful for that. You can lay out your buildings. You do your diagonals on your buildings. Let's say this is using the Pythagorean theorem. Let's see, that's Control I. No, let's just get rid of that. 2 decimal places. So if this was the actual size of the building, you go to get the diagonal, so you'd be doing the same thing. You'd go out here, you're going to have like your control. So you've established these 2 points. You can swing an arc from here to here. Let's say we don't know where this is yet, right? We just got these 2 points. One second. So you need to know, you have these 2 points that are established. We're going to swing an arc that's 63.35. And then the other arc's going to go from here, F3, and then the 63.5, so it's going to be square root, open parentheses, 63.35 squared plus 56.33 squared, close parenthesis, and then enter, and then it'll be from this one to here. Right? And then from here to there will be 90 degrees. At a 60 feet, you're going to start wanting to take it, depending on the tape measure you got, you're going to want to take into account sag. Some of the really light tapes, it's not an issue. Up to 100 feet, you're only going to gain an eighth. Some of the really like half-inch, really thin ones, so I think there's a Fat Max that's super thin. It's nice, like doesn't sag. But if you're going to do nichrome or some of the heavier ones, they're better, but you actually have to calculate in the sag at 63 feet, 70 feet. It's going to be substantial, probably close to 1/4 of an inch. And then that's it. That's how you do that. And then you just swing the arcs like the same as the footings, right? 56. Then you could do the same thing, right? You could swing that arc out this way. F3 and 63.35. Yeah. Then you get your corners. You could actually get your offsets from doing that same thing too. But anyways, that's how you get your corners. And then you double check this, you know, the diagonals are the same, that the widths are the same. So this is very important when you're doing that. Double check the lengths, that they're the same, that they are what they're supposed to be. And then you check the diagonals to make sure they're the same. Because if the lengths aren't the same, you're going to have, oh, you could end up with the same diagonals, but let's say that's 56.33 and that's 56.25. You have an inch difference or an inch and a half difference, you could end up with the big, these diagonals would be the same, but they could be the same, but you wouldn't be square. So these have to be the same length, right? This side and this side, opposites, right? Otherwise, you could end up with a trapezoid that looks something like this. So these diagonals are the same, but you're definitely not square, right? So I had that come up on an elevator. Somebody called me and asked for some help, and that ended up being the problem, the solution. We just had to make sure that they were the same. So if you just go and you do that diagonal A after the lines are up, you can make a mistake. So you really want to calculate what the diagonal is supposed to be. Don't just assume that if you get the legs up and then you'd run your diagonals, so the same, you're square. And then that's it. That 1.4142 is very important because it makes laying out squares easy. The 345 is very important because any ratio of 345, it could be, so you could go 3 point, let's say go 3. So there's start going off the deep end. It's just better to know the Pythagorean triples that you want to use, and then know how to do the Pythagorean theorem, and then use this square root of 2. That's about it. I don't think if you could go your whole career and not need to know any more than that. You start getting into trig, that's great too, but not necessary for laying out something that you have the sides for. It's good for calculating unknown sides with different angles. Let's say you had a footing that was in an angle, then you want to know something like this, right? If you went, and then let's say V control JC70 So if you knew this was alt MA, that's 70 degrees, then you could use the Pythagorean theorem, no, the trigonometry, which, and then you just got to make a triangle, HK, enter, and get rid of that. So that becomes a triangle, and you know that's 70, and then you know, let's say the width here is 53.35. Let's say that's how far away that point's got to be at that angle from here. So this is a predetermined point. All right, that's a predetermined point, and this is a predetermined distance, right, away. So you don't have this, you have this only. Yeah, this is your baseline, and from this point you need to go 70 degrees. So you don't have anything else, right? So what you got to do is you got to go, okay, so you got to create your triangle. The way I do it is just sketch out my triangle like this. This is 70. And this is 53.34. And I got to lay that out so I can go, I know this is the leg, this is the opposite leg, and this is the adjacent leg, right? So opposite over to adjacent is called the tangent. So the 53.34 over A is equal to tangent 70, right? And then you use your algebra to solve for A. It ends up being 253.35 or 53.34 divided by open parenthesis, no, not divided by tangent, TAN, open parenthesis, 70. All right. Let me copy that. Control C. Hit the compute. Control V equals, make sure it's blowing up so you can see it. Control V. This is pretty common. So 53 divided by tangent of 70, so 19.4142, right? So we're going to measure over a relative 19.4142, enter. All right, so then from that one, you know, and then we got to figure out what's the diagonal. You could use, now that we have this leg and this leg, we could use a Pythagorean theorem to get that, but since we're using the trig, we can use the same number. So this over the opposite, 70 over the hypotenuse, is the sine. So we'll go 53.34 over H equal to sine 70, right? So we'll do the same thing there. 53.34 divided by sine of 20, open parenthesis, 20, close parenthesis, copy, compute, Control V. I think something's wrong. It's looking like a really big number. 53.34 over X is the sine of 70. 53, and then 53 over H is the sine of 20. So 53.34 divided by sine of 20 divided by, that would be it. Copy. 155, there's something wrong with that, right? It seems like it'd be odd because the sine of 70 should be really close to 1. It is sine of 70. 0.9, right? Why would 53 divided by 0.9 end up being 150? So 53.34 divided by, copy, repeat. Yeah, that sounds better. Make control V equals, I don't know, control C, control V. That's what it should be. But why would that 53.34 divided by sine of, I think I put in 20, 70, I think I put in 20 degrees. Yeah, because I was thinking this angle, 20. That's going to be better. 58.732, that's it. So then you do, that's the arc you would swing right here. Control V, enter. You'd swing it over here. All right, and then the same thing over here. F3, 53.34. Right, because you don't, let's say you don't have that, you just know the dimension, and then that gives you your B from there to there, and that's your 70 up. Then A, that's your 70 degrees. All right. So, anyways, that turns out to be a long time, but I don't know. I learned this stuff out of a workbook 30 years ago. That wasn't easy either. So, sitting through these videos is work too, I'm sure. I hope that helps in your career, and thanks for watching.